All right, so I am WanderingGlitch, and this is a little less conversation, a little more ActionScript. And all right, so I am Jaisal Spellman, but really WanderingGlitch. I focus on static analysis of binaries, mostly client-side vulnerabilities on both user land and kernel. Sometimes go into remote side, but it's almost always binaries itself that I'm looking at this point. And in addition to that, I write a lot of augmentation or a lot of automation code to augment my abilities. I started off kind of in the development mindset, and whenever I am breaking anything, I try to build stuff to help me break it better. I do all this for the Trend Micro Zero-Day Initiative. We're the largest vendor-agnostic bug bounty program. We're actually one of the sponsors here. Thank you again, Infosec Southwest. And we do a lot of vulnerability discovery and remediation. We reported 600 and something vulnerabilities that all got patched last year. And our team was responsible for about a quarter of those. In addition, we try and research advanced exploitation techniques, because if we're looking at vulnerabilities, we need to know what's actually useful and what they're worth, and we won't know unless we actually write exploits for them. And as part of that, we are one of the top suppliers of vulnerabilities and CVEs to Microsoft and Adobe for the last at least 3, maybe longer years. I also want to point out that this is more of a reverse engineering talk than a here's a bunch of bugs talk, specifically because I only have 2 bugs in Flash. They got patched either December or January. And as a completely random aside, I love to travel these days and have been to 5 continents this year. Hopefully we'll hit all 7. Just kind of awesome. Australia and Africa are the ones I have left. So before I go into the actual meat of my talk, I'm going to talk about what ActionScript is, and specifically a delineation between ActionScript 2 and ActionScript 3, AS2 and AS3. Most of the differences are not really relevant for us, but there's a lot of API differences. AS3 is actively being developed on, whereas AS2 is not really being developed on. There's some behind-the-scene JIT differences which do matter if you're going to exploit things. There's some memory isolation differences, stuff like that. The main thing we care about is that they're both based on ECMAScript, and within ActionScript 3, you have type enforcement at the language layer rather than when you're using it, and I'll talk about that in the next slide. Here's an example of what ActionScript 2 looks like. If anyone's ever done anything with JavaScript or ECMAScript-based languages at all, this will look very, very familiar. But just to be overt about it, we have this greeter class, which extends movie clip, and we're instantiating a variable, text hello, doing so by calling this.createText field, which is getting a string and then a few integers, and then we're assigning the .text property to be hello world. This is all fine and good, but all of this is occurring let me rephrase. If text field is a native class, and what I mean by that is it's implemented solely in C code as opposed to ActionScript code, then this will go into C code through some boxing code, and all of the type coercions and type checks will happen within the C function rather than being done within the ActionScript 2 virtual machine where it's safer. So when it goes to apply the .text property, it may or may not know that it's supposed to be a string or what it's supposed to be. It just knows that when it goes to assign it, it's going to try and take the hello world string and cast it to a string. If it can't, then it'll throw an error, or if it's not a string but it can become a string, it'll call a custom function and things will happen. That fact alone is why ActionScript 2 has had so many use after frees in the recent past. Here's an example of ActionScript 3. The exact same code also from Wikipedia. I modified it slightly to point one thing out, and that's specifically you have var text hello text field. What that means is that text hello is now a text field object, or a text field instance, and so the only thing you can apply to that variable is a text field instance or a instance of some other class that inherits from text field. Additionally, text hello has a text property, and that is defined to be only a string. So when you assign it, it will become a string the second it gets assigned, and that all happens within the ActionScript 3 virtual machine and not in C land. Going back to what I'm actually interested about telling you guys, I'm kind of approaching this talk from the eyes of a reverse engineer the eyes of someone looking at a lot of cases. And this is usually what a crash in Adobe Flash looks like. It is worthless. For those that see a lot of WinDbg, you'll notice it's especially worthless because I accidentally cropped off EDI. But even if you could see the register value, it's useless. Additionally, if you have 40, 50 of these Flash bugs at any given point waiting for Adobe to patch them, there's no real clear indication as to whether or not this bug is unique across the corpus you have. Partially because vector may be, the bug itself may be different, but the crash point may be the same, or just really all sorts of reasons. The crash alone is worthless. If you were to look at a call stack, thank you very much, HT. If you were to look at the call stack, you would just see a bunch of gobbledygook. It would not even make it all the way back to the base thread start. It would on 64-bit, but all the functions would be Flash player and then some random offset. There are people that do have access to those symbols, like Google, Microsoft, Adobe, and any other partners that they officially have partnered with, but we're not one of those. Given that, I will sometimes just look at the proof of concept to try and understand what the bug is. And I chose this particular bug. I don't remember the CVE. It was used in Pwn2Own either 2014 or 2015. The reason I chose this bug is the exact same bug exists both in ActionScript 2 and ActionScript 3, which makes for a good kind of walk through both. So if we look at the proof of concept, there are 3 or 4 things that stick out immediately. First line, you instantiate a convolution filter object, and you save off the reference. Then you have this generic object with a custom value of function. The custom value of function does a mutation on the convolution filter object. It modifies the matrix X property. Then it does what appears to be some sort of reclamation spray, basically allocating a bunch of objects that, in this case, probably will fill a freed buffer. And then you return an integer. If we then look at the last line, we have an assignment to the convolution filter, to the .matrix property, and we're assigning an array. And within the array, we have the custom object followed by 4 integers. We know that the custom object is eventually going to call or return a integer if you call value of. So just looking at the proof of concept, we can kind of surmise that matrix should only be an array of integers. And when it goes to assign it, if I was to develop it or think about how a Adobe developer may develop this, then you may hold on a pointer to your .matrix property as you are about to fill it in, and then iterate through your argument. And when it goes to do that, it then frees the pointer that you're holding a reference to because you're modifying matrix X, which is one of the properties, one of the fields within the array that you're accessing and working on. This is basically a redefinition reentrance attack, and this is essentially how most of the use after freeze ended up looking in ActionScript 2. But this one's ActionScript 3. If we then try and prove that this is actually the case by bringing what we have back into IDA, and we just do a simple string search in IDA for convolution filter. Looking back, I probably should have used matrix X as the needle, as that is the most unique kind of value or string I could have used, but I used convolution filter for whatever reason, and we have a bunch of hits. The first one is absolutely worthless, though. We end up having a text string null terminated within a sea of null terminated strings. If you go 2,000 bytes above or below, you will see absolutely nothing, and it is just worthless. So I wrote some quick IDA Python and just do something very gross. It started off at the C at a DB 5318, and it just kept going one address up over and over again until it saw some address within the program that had a reference to it, so something that was actually using it. If we do that, we end up with this beautiful string that starts with FWS. For those that don't know what FWS means, it's one of the magic bytes that starts off a SWIFT, FWC being another one if it was compressed, but it means that there must be a SWIFT that's embedded inside flash.ocx or flash debugger projector. If you look at the bottom part, at the code that's actually referencing it, there's a push of hex 9C89 right adjacent to the push of this reference to the string. So all I did was called IDA API get many bytes and grabbed hex 9C89 bytes, wrote it out to disk, and then threw that into a freely available decompiler. I use FFdeck, JPEX, but really anything would work. And you end up with a bunch of ActionScript 2. And if you look at the ActionScript 2 that's there, you'll notice that these are all the APIs that Adobe officially supports for ActionScript 2. You'll see a lot of calls where something is being set to the return value of ASNative. There's another similar function called ASConstructor, and both ASNative and ASConstructor always take exactly 2 integer arguments. In addition to that, you see a bunch of ASSetNative and ASSetNative accessor, and those are used, as far as I can tell, to apply properties on various ActionScript 2 objects and classes. One issue with this is looking through everything, you'll see every API that's ever used. You'll never see ASNative or ASConstructor ever defined, and so it must be defined elsewhere. So doing a string search just for ASNative, we see exactly 2 hits. We see one that is within the Swift that we just dumped, which, okay, that's good. We have confirmation that is indeed there. And then we have another one that has a data reference to it. And if we look at the one that has a data reference to it, it is pushed onto the stack, and right adjacent to it is a function that's pushed onto it. Kind of ruin things by showing the name here, but it's AS2NC handler is what I called it, native code handler. And then an integer is pushed adjacent to that, 0 or 1, 0 for ASNative, 1 for ASConstructor. What ends up happening is within AS2 native code handler, it does a check to make sure it has exactly 2 arguments, and that those arguments are either integers or coercible into integers. Once it's done that, it then calls this other function. This other function then iterates through a native table, AS2 native table, and it does a comparison against a static value. And so if I find this just programmatically, I can then see where the AS2 native code table is defined, as well as the size of the table. Looking at the table itself, it's fairly straightforward. It is integer and then offset to some handler, and integer, so on and so forth. I've renamed them just with AS2 underscore the hex ID and then the decimal ID so that I had easy ways of looking things up as I was going through things. If we then look at what the initial ActionScript 2 snippet I showed looks like, we'll see that escape and unescape and parseInt, even though that's not visible here, all seem to go through the same kind of handler. That first value is all the same, but the second value is, it varies for all of them. It's 0, 1, 2, so on and so forth. That second value is something I've been calling the method ID, whereas the first one I've just been calling the object ID or native code ID. What you'll see is that within each of these native code handlers, there's effectively a series of nested ifs or a switch table that's used to parse through and decide what all to do. Additionally, you have ASSetNative and ASSetNative accessor, where you would potentially have an object, an integer saying the native code handler to use, a string specifying all the properties, and then you have an optional integer. If you have the optional integer, it's the starting point for the method IDs, the property IDs, whatever you want to call them. If you don't, then it just starts off at 0. And you'll notice that these have numbers before the property names. Those are just flags that get parsed. Here's just some random AS2 native code handler, and the reason for showing this is just to show that there's a switch statement that parses through and acts differently based on the value, based on the method ID. And so I have, as part of my code, I go through and I add type information to all the native code handlers, and then it makes it very easy to see exactly what is going to be dealing with what. Just an AS2 arg structure. It's best I could do. If we go back to the bug itself, because I did say the convolution filter bug is in both ActionScript 2 and 3, we then see that convolution filter is defined by the native code handler for 1109. The object itself will get instantiated when you go through the 0th switch index, and then you have all these native accessor methods. We can also see that it kind of inherits from the bitmap filter class. And matrix X is going to be method ID 1 and 2. So 1 if we are reading, 2 if we're setting. I may actually have that backwards. Regardless, it's 1 and 2. And then the matrix property itself is method ID 5 and 6. So using this, we can just go to the native code handler for 1109, look at the switch table, and look at options 5 and 6 and 1 and 2 to see exactly where it's freeing. I would show that, but there's a few dynamic calls in the way, and it doesn't look quite as clean. But we were looking for a ActionScript 3 vulnerability, not an ActionScript 2 vulnerability. So continue on looking for other references to convolution filter within the binary. And we end up with, and if we do the exact same trick of, OK, we now see a string, let's go up until we see a data reference, we see this. And I don't know if that is immediately clear to anyone else, but it wasn't to me. I actually had no idea how to proceed at this point. I had an idea that it was somehow ActionScript 3 bytecode within the binary, but I wasn't quite sure how to parse it, what to do with it once I did parse it. Thankfully, AVM Plus is at least partially open source. And although the AVM ActionScript virtual machine and ActionScript bytecode documentation is quite fantastic and does describe everything, the implementation itself is very, very readable. And so I was able to use that to create my own bytecode parser. There was still the issue of where do some of these functions come in from, but the AVM Plus code shows that as well. So you have this native initializer class, and it takes this built-in AOT info. That is the giant blob that contains all the bytecode. And then you have a method count and class count, and then you parse two tables of class entries and method entries. If we look at the assembly itself, it looks exactly the same if you're at least doing it on a debug build. The production builds change things up a little bit, but it's effectively the exact same thing, and can use this to start parsing through and renaming functions. One thing I didn't realize until I was looking at the binary itself is that there is another embedded ActionScript bytecode. This one is built in, whereas this other one is shell top level. I don't fully know what the distinguishing parts are for why some objects are in built-in versus shell top level. I know that the object class, that's defined in shell top level, whereas convolution filter, a lot of the proprietary APIs are all in built-in. But if you look at AVM Plus, there's not a one-to-one matching, and even classes that are implemented in the open source components are not actually present necessarily here. As far as the ActionScript bytecode itself is concerned, it's parsing. You have to parse a bunch of pools. So you have constant pools, integers, uints, doubles. Floats are optional. They have code for it to handle it in the AVM Plus source tree, but they don't actually use it. Strings, namespaces. You have to parse all of this in order to know, say, that convolution filter is the name of a particular class, because it always uses reference IDs. So it'll say, I'm going to use something from the string constant pool, and then I'm going to use the index for convolution filter. After parsing that, you have to go through and get method information and return type information, stuff like that. Metadata is stuff that I'm completely ignoring. Then you have instance information, so the types, the namespaces, the interfaces that define them, where the custom initializer, the constructor is. Same applies for script, class information and script information, and then body method body information I largely ignore. Some of it's useful as far as knowing what parameters the methods will take, but for the most part, I'm not really looking into that. I've mentioned traits a few times in these slides. It's effectively like tags, attributes. The traits end up being things like trait getter, trait setter, trait method, class, whether it's const or not, things like that. Looking more at the AVM Plus source tree, there's a struct native class info. This is what the fill-in classes function ends up using. And it is just an array of native class infos. So once you've parsed the class information within the ActionScript bytecode, I can just go through the binary and search for these, look for anything where the class ID matches, and I immediately can then rename the class closure. The sizes and the offsets, so the size of the class and the size of instance, and then offsets to the various properties, is incredibly useful when you're doing actual analysis, but that's for the in-memory you're running portion, and for the most part, I'm trying to do this statically so that I have a way of automatically renaming and rerunning my script every month when Microsoft patches, or when Adobe patches. And this is just what it looks like. Not really the best to look at, but you can see that I can at least rename this flash sampler stack frame. Native methods are the exact same. They do have a couple of if-defs. The VMCFG AOT is always enabled. It's the ahead of time compiler. And effectively, we always have a handler method, we always have a thunker, and then we always have a method ID. And so it's the exact same thing of parse all of these out once you find the base of the table, and then just match up based on the IDs where they match to everything inside the ActionScript bytecode that you're looking at. And in the binary itself, it just ends up looking like this. So as part of reversing as a general rule, I like to do verification and validation, especially when I feel I'm in unknown territory. So one thing that was available that I found out only after I wrote my own bytecode parser was something called RABC DASM, ActionScript Bytecode Disassembler, and it was written by a guy called Cybershadow, and it's way better than my bytecode parser, but it's written in D, so I would not have been able to fully utilize it from IDA anyway. But it's fantastic in that I could throw it at the ActionScript bytecode that I was pulling out from IDA, and I could compare it against the official APIs. The official APIs in this case being playerglobal.swc, which is released by Adobe every month, every time they release any patches. And it's basically what you effectively think of it as a library that you can kind of link and build against every time you want to build a Flash project. And the nice thing here is it matches up exactly. So I'm looking at the result of RABC DASM at the top, and then the result of decompiling player global at the bottom. And it all matches up. Flag 0hex20 just says that it's a native function. And apparently Cybershadow's code doesn't quite know that or is not documenting that properly. If we look at the body itself, we don't have to pay attention to this, but I'd still like to verify everything. We see that this also matches. And so we have a couple lines after the code block. We have get local 0, construct super, then get local 0, get local 1, init property matrix x, which matches the first 2 lines on the right side where you have a call to super, and then you have an assignment to this matrix x property from the matrix x argument. Now, as further comparison and validation, I am comparing RABC DASM's output to my output. So the top is RABC DASM, and the bottom is mine. And if we start in the middle and kind of work our way out, except for ignoring optional false, we have flag hex 20 and flag optional, which matches the 40, so 32 and 8. It returns a void. It takes a display object, 2 uints, and a Boolean. And the way that optional arguments work in ActionScript 3 is that they work basically from the right to the left. So in this case, Boolean is equal to false as the default argument. And at the bottom of my part, you can see that it's also using false. And if we look at the actual official APIs, it's the exact same. And so we have at least confirmation that my bytecode parser is indeed doing everything I think and expect it to. Looking more around the code, they have a lot of horribly defined macros. Adobe really loves their macros, and they're using it to define functions, but in the debug build, so only if you're looking at the debugger projector, you'll see extra strings in some of the structs. And you can use that as a heuristic to then find what those functions look like. And based on what they look like in the debug builds, you can then kind of look for them and hunt for them in the production builds. But in general, it just makes it much easier to reverse out and understand things. This page is not this slide is not the easiest to see, but in the top call info in the bottom picture, you have an extra parameter where it's a pound name, where it's doing stringification and just storing a pointer to an extra string. And if we look at the struct for call info, we'll see that there's a constant character name that is only there when it's in verbose mode, in debug mode. And if we look at what it looks like in the binary itself, we can see that we have a pointer to some function that I've now renamed, a integer dword specifying return type and parameter types, and then a dword that is largely ignored, followed by a pointer to the function name that I'm actually using. Using that heuristic, I'm able to find, I think it's actually grown, but at least 208 call info structures. And then the most recent thing I've done as far as heuristics go is I already had access to the class closures as part of parsing ActionScript bytecode. And if you look at in the generated subdirectory of AVM+, you'll see that they have a lot of these class closures that set up the instantiation procedure for objects. If you look at the instantiation procedure, you get the vtables that are going to be used, as well as the extra size, stuff like that. The most important thing about this being that the only way to get vtables for any of the ActionScript 3 script objects is to parse that function and we'll be able to see it. The create class closure functions all get called as part of standing up the AVM, but the create instance procedures only get called when you actually call, say, a new convolution filter or whatever, like the first line from the proof of concept. And as I was saying, already have access to the class closures, so if we then do some heuristics and just look for writes to that offset, where you also have a pointer, you now have access to the create instance procedure. Altogether, I'm finding, actually these numbers are slightly wrong, but I'm finding 6,000 to 7,000 functions and renaming them, I guess addresses in general. And it's just so much easier when you can kind of set breakpoints and you know exactly what the code is going to execute based on what the proof of concept is. So I could set breakpoints on the convolution filter instantiation procedure, the assignment for the matrix X property for the matrix property, and I can see where all these frees are happening, where it is holding the reference when it should not have, basically everything. And with that, I'm going to show real quick. Hopefully this actually works. That did not work. Show. That is not working at all. All right, I'm going to try and show demo if it plays along. Did I what? Are you willing? Is that a volunteer? All right, so it works fairly cleanly. I run this every month, and I've only had to tweak it a little bit as far as getting things to work again. On the debug builds, it typically works every time, whereas on the production builds, because I am using heuristics to find a few of the functions, it doesn't always work. And this is a fresh IDB, nothing has been done to it before. And at this point, if we wanted to say, look at where convolution filter was in ActionScript 2, it ends up being right here. And if we do, well, that's going to be pretty unreadable. But we can see where it's grabbing the method ID. And so we could see and iterate through each of the cases for matrix X, for matrix C, everything. If we wanted to look at where convolution filter is instantiated, we can look at this guy, and we'll see where the vtable is coming from. If we wanted to look at where the setter for, that's the thunker, this guy, we can see exactly where in the code it is. And we also have some type information that I'm not cleanly displaying, but I can at least programmatically say that, all right, this is going to return nothing, and it's taking an array. Or if I'm looking at, say, this guy, the getter, which is used for leaking information in this case, you can see that it's going to return an array. And just that stuff ends up being very, very handy. For the call info structures, those end up looking not like that. Whoa. Coerce. Go. There we go. And the nicest thing about all the call info structures is that using them, I can find a lot of the type coercion functions, like in this case, string, or number, or integer, float, double, all those. And using that, it makes it so much easier to then know where you could potentially call value of, and why value of it is being called, value of or toString are being called in various places. Go over here. Play from her side. Cool. And with that, I'm pretty much done. There's a tweet from Chowki Bekrar from Vupin, former, or I guess now Zerodium, where he's talking about how a lot of the Flash bugs have been in ActionScript 2, not ActionScript 3. And I think a huge part of it is that ActionScript 3 has the type enforcement at the language layer, but also it is so much more difficult to reverse anything in ActionScript 3 because you have to have a bytecode parser. And a lot of the people I know that are finding bugs in ActionScript 3 they're just doing effectively dumb fuzzing. And it is working. There are use after frees in ActionScript 3, but they're nowhere near as easy to trigger or as easy to find as in ActionScript 2. Kind of cover that. Automation is definitely key. The fact that they update every month is horribly painful. I've done similar work for Adobe Reader, but they only patch quarterly. So if you want to do bug triage and deduplication, it's actually possible there. With Flash, we needed something to be able to distinguish. rerunning the 40, 50 POCs that we have live at any given time, it's not as feasible. And you need something. You need to be able to say definitively where the bugs are. And there's still more work to be done. As far as automatically renaming virtual methods, I started doing that, but I ran into some issues because I'm depending on heuristics. And PDB generation has been a huge pain. I'm finally to a point where I can at least emit PDBs that will get parsed by IDA, Windowbug, CBDump, all sorts of things, but can't quite get the structures right where it's actually using my new strings. Although my code is only ever run against Flash Debugger Projector or Flash.ocx, this also would work on Pepperflash, the one that's baked into Chrome. However, some of the heuristics will definitely break as I'm looking for different patterns, and they highly optimize everything. They also they turn a lot of asserts into hard failures, specifically so that things are less likely to be exploitable. And that just makes things more difficult. And with that, I am super early, but I'm WanderingGlitch from the 0 Day Initiative. Does anyone have any questions? Thank you.